In this video, you are asked to find the volume generated by revolving y equals cosine of 4x about the x-axis between x equals 0 and x equals pi over 8. So the first thing that you need to do, as always, is to go into Desmos, graph this function in Desmos, and identify the bounds of integration, and then just draw a little sketch here on your paper. So this is going to look something like this. Our function is going to come down kind of like that. And so this point right here is going to be pi over 8. And of course, this point right here is going to be 0. Those are our bounds of integration. So what I want to do is I want to draw a representative rectangle in here. So I'm just going to draw a representative rectangle. And that rectangle is going to look something like this. Now, we're revolving this around the x-axis. And with the rectangle that looks like this, then clearly we are going to be integrating with respect to x. And the disk method would be the method that we would want to use. Now, it didn't specify to use the disk method, cylindrical shells, or anything like that. But knowing what the graph looks like, looking at which axis we want to rotate it about, draw yourself a rectangle and come up with the method that would be the most efficient at accomplishing your objective, which is to find the volume. And so I'm going to use the disk method for this problem. All right, so we've drawn our picture and we've identified the method for finding the volume. So the basic formula for that, for the disk method, is the integral from a to b of pi times f of x squared dx. So f of x in this particular case is cosine of 4x. Our bounds of integration are 0 and pi over 8. So we have the volume from 0 to pi over 8. Let's bring pi out here, get rid of that constant. And so then we're going to have the cosine of 4x, and that's squared dx. So immediately I see I have a cosine squared problem. And so in the section on trigonometric integrals, we have learned how to deal with that type of a problem. We're going to use our identity. And so we're going to rewrite this as pi over 8 as 1/2 plus 1/2 cosine of 2 times the given angle. Well, the given angle was 4x, so that means we're going to have 8x here. All right, now we're going to break that into two separate integration problems. I'm going to break this into the volume equals pi times the integral from 0 to pi over 8 of 1/2 d theta plus, or I'm sorry, dx, not d theta, dx, plus pi times the integral from 0 to pi over 8 of 1/2 cosine of 8x dx. And simplifying this a little bit, bring the 1/2 out in front, so we have 1/2 pi, and that just leaves me with dx in here, and bring out the 1/2 times the pi. I like to go through and do this very methodically. And so we need to integrate the cosine of 8x. Well, let's start with the integral on the left. The volume is going to be equal to 1/2 pi. And so that's going to be x integrated from 0 pi over 8. And then over here, we're going to have 1/2 pi. And because this is going to be a u substitution problem, first of all, the antiderivative cosine is sine. So we're going to have a sine of 8x. And then we're also going to have that 1/8, which is going to be part of the u substitution for doing the cosine of u. All right, and then that is also going to be evaluated from 0 to pi over 8. And now we can combine these. I know I break up the problem into two separate integration problems because sometimes it's simpler to do that, but then when you evaluate it, I like to put it all back into just one problem again. So volume is equal to 1/2 pi, 1/2 pi. And so I'm basically factoring that out. We're going to have x plus the 1/8 sine of 8x my pen keeps getting screwy on me here, from pi over 8 to 0. Well, at this point in time, it's just a matter of substituting in. So we have the volume is equal to 1/2 pi. And so then we're going to have pi over 8 plus 1/8 times the sine of pi over 8 times 8 minus, and we can put big brackets right here, minus 0 plus 1/8. The sine of 8 times 0 is going to be the sine of 0. And then we're getting close. So the volume is 1/2 pi times pi over 8. And now the sine of 8 divided by 8 is just the sine of pi. The sine of pi is 0, so all of this just becomes 0 minus, over here, the sine of 0 is 0, so all of this just becomes minus 0. And so what we have here is the volume is 1/2 pi times pi over 8, which is, when we simplify that, pi squared over 16 in simplified exact form, or 0.617. And that would be the volume generated by revolving y equals cosine of 4x about the x-axis between 0 and pi over 8. Hope you enjoyed the video.